In Geometry 7.4, we're dealing with parallel lines and proportional parts. And we have several theorems that we're going to go over before we can do this section. The first one is a triangle proportionality theorem. And basically that states if I draw a line anywhere in the triangle, doesn't matter where in the triangle, as long as it's parallel, okay, to one of the sides. So if I drew it this way and it's parallel to here, then I created a proportion. So what that means is if I draw a line so that BD is parallel to AE, it could be here, it could be up here, it doesn't matter where, then the proportion between BA to CB is equal to the proportion between DE and CD. They're the same proportion, same fraction, because this starts in the same place as this. This starts on this line, the same place it starts here on this line, because they're parallel. So there's that proportion, but then we have the triangle mid-segment theorem. That means if I took this and I put it exactly in the middle, so that means if B was the midpoint between line AC, and D was the midpoint between CE, and midpoint means that then AB equals BC, and CD equals DE, once they're parallel, automatically this line right here, BD, this still applies, of course, but this is half the size of AE, or AE is twice the size of BD. So this one tells me about B sides. It gives me an equal proportion of the side. And as long as this is the mid-segment, okay, then I can say that the actual lines, okay, are half. And these also have to be parallel, just like in this case. Right, so go ahead and write that down, do your vocabulary. And we have about two more theorems that we're going to go over, and then we can start our example problems. Okay, the first one, well, these are not theorems, they're corollaries that kind of play off of the two theorems that we went over. They're corollaries 7.1 and 7.2. And these are a lot of words, but basically I'm dealing with parallel lines. If, okay, these lines right here are all parallel to each other, then AB over BC is the same. It's whatever it is on the other side, their proportions are the same. So AB over BC is the same proportion as DE over EF. Please remember, they're not equal. It's not telling you that AB equals DE. It means that the ratio between AB over BC is the same ratio between DE over EF. And the same thing can be said about these proportions. AC over DF, basically because these are parallel, this line then mirrors this line. Even though they're not the exact same, they don't have to be the exact same, equal, they still, right, they're still proportionate to each other. Corollaries 7.2 says that if AB equals BC, so if this equals this, then this has to equal this because they're parallel. So they start here at a certain point as they start here, and the same thing here. So AB, if AB equals BC, then DE equals EF. Same thing can be said the other way. If DE equals EF, then AB equals BC. So these give us proportions that equal to each other. These give us actual lines that are equal to each other. So go ahead and pause it, write it down, and then we're going to do some example problems to wrap the video up. Okay, this is example 1. It wants us to find SU. So I've labeled SU as X. And basically, if we do theorem, this is a triangle. So if I tell you that these are parallel, I can apply the triangle proportionality theorem. It says that if this is parallel to this, okay, then my parts, so that means SV over RV is equal to SU over UT. I have to be, I have to make sure that I keep the consistency. So if SV comes from the top, I have to do the top for SU, and RV and UT. So in this case, now I just fill it in. This is the most difficult part again. Okay? Once I have this, okay, once I use a theorem to find this out, then I can go ahead and just solve and cross multiply. SV is 3, okay? RV is 8. SU is X. And UT is 12. So then I end up with 36 equals 8X. Divide both sides by 8. I end up with X equals, 36 divided by 4.5. Alright, so we have, X equals 4.5. Now, X is also SU, so I can say SU equals 4.5. And that's my answer. The next one, it wants me to find X and Y. Okay? It tells me here by these little lines that this is the same as this. So I know for sure that 2x plus 2 equals 3x minus 4. That one I know for sure. But I also know that according to the last corollary we went over, corollary 7.2, if this is parallel, and they are supposed to be parallel, my apologies. If these are parallel to each other, then this also equals this. So I can also say that, I'll write it over here, 8 over 3y plus 7 equals 5y. Okay? So then we can solve both questions. Now, these are what I set up. After that, we're just dealing with algebra. So with algebra, let's go ahead and solve. Let's solve this one first. It's a little easier. I'm going to subtract both sides by 2. And I end up with 2x equals 3x minus 6. Then I'm going to subtract both sides by 3x. I end up with a negative x equals negative 6. I divide both sides by negative 1, because this is negative 1, because my x cannot be negative, and this cancels out, so I end up with x equals positive 6. So I found x. Now y, I have a fraction, and we're not big fans of fraction. But this is a pretty simple problem to fix with a fraction, because basically, if I take the denominator of this fraction and multiply every term, then this would not be a fraction anymore. So if I multiply this by 3, this cancels out and I end up with an 8y. But in order to keep the equation balanced, every term, that's anything that's separated by a plus, minus, or equal sign, every term needs to be multiplied by that same number too. So if I multiply this by 3, I have to multiply 7 by 3, and I have to multiply 5 by 3 in order to keep the equation balanced. So I have plus 21 equals 15y. Okay? So, then I'm going to subtract 8y from both sides. I end up with 21 equals 7y. I divide by 7. I end up with y equals 3. So my answer here is y equals 3 and x equals 6. So go ahead and do page 410, number 2 and 4. 410, number 2 and 4, and I will see you in class.